what's going on there. And now we're going to hear from Professor Luis Muñoz, who comes from Spain. He tells me he's from Santander. And he is going to talk about what he calls massive IoT deployment. And when I heard that, I thought, oh, maybe we'll be dealing with billions of devices, but he's probably ahead of most other people. He's talking about, what, tens of thousands, I guess. And so we'll hear about what's going on in there. And then if we have time, we'll take a few questions after that. Thank you.
Thank you. So let's start the last talk. It is a pity, so it's the last one. So I hope not to be too long in the discussion. The talk on the massive IoT deployment on the city at the city scale. So the idea is that I will be providing you many of the details that have been covered in the past by the colleagues in the previous presentations. Indeed, the point is that also I change and I try to fit to the, let's say, to the comments that have been provided with very nice and interesting ideas, and to see how all these ideas, in a certain extent, are accommodated in this concept of a smart city, relying on a huge population of IoT devices. So what is the SmartSantander project? This is a city-scale experimental facility. So we have started as a city-scale experimental facility, let's say, supporting the research and experimentation in terms of IoT architectures, services, etc. So the important point is that, and I would say that the differentiator factor at that moment, 5 years ago, was that besides, let's say, deploying an experimental facility, from the very beginning, we conceived such facility as also supporting in a concurrent way the service provision to the inhabitants, to the municipality, and to the different stakeholders. Before, let's say, starting the real deployment, we made an analysis of which were the characteristics in terms of which are, let's say, the experimental facilities which were available at that moment. You can see here some of the KPIs, some of the metrics that can allow us to assess about the main hints on the experimental platforms. So issues such as heterogeneity, concurrency, mobility, repeatability are key characteristics in terms of deploying, conceiving an experimental facility. Beyond that, and based on the fact that we aim at having such a deployment in the framework of a city, and beyond, let's say, trying to cope or trying, let's say, to implement an omnidirectional pattern in terms of the KPIs, a very important factor, a new dimension, was the sustainability. So one of the main problems that we were discussing also with the Commission is that beyond, let's say, the life of the project, most of the experimental facilities, let's say, expect problems in terms of sustainability. So one of the key issues for us was to guarantee the sustainability of the platform, taking into account that we were developing such platform, or we were deploying such platform in the framework of the city. So the approach that we follow can be synthesized in these 4 points. So the idea of building an open platform for supporting, let's say, the experimentation on top of the IoT technologies, then to provide a set of initial services for the benefit of the city and the citizens. So the idea that we deploy an infrastructure that is going to support, let's say, the needs, the present and future needs of the citizens. This is an important aspect because, in a third derivative, allows to foster an innovation ecosystem. So we have realized, and later on I will come with some details, how things change by the fact that an aspect like, let's say, the technology deployment and the fact that the citizen is involved in this sphere of technology makes the city and the citizens feel in a better position and also suffering the criticism of the citizens. So this is just a slide making familiar to all of you with Santander. Many people think in Cantabria like Calabria in the Italy. This is not the case. We are in Spain, and we are not in the south. We are in the north of Spain. So this is a small city, but has been quite active in the last 5 years in the smart city arena. The deployment that we address had at the very beginning a twofold objective. So the first one was to provide an IoT deployment, massive, what is called, we call at that moment massive IoT deployment. So now, as Bob said just before, we are discussing about billions of devices. And the second important point is, besides having this infrastructure for supporting the experimentation, as I have just said, also to provide services for the citizens, but also services for experimenting on top of them. The last point that has been attracted a lot of attention, let's say, in the last 1-2 years, is the concept of co-creating. So how we can embed the citizen in this domain. Now we are in the process, I will explain at the end of the presentation, of this concept of co-creation. So how the citizen participates in an active way in creating the technology, in creating the services. This is the architecture that supports the SmartSantander concept. This is an architecture fully operative. Now it's being migrated in the whole, let's say, fiber concept that also I will explain. So the main points is that we are supporting in this plane the experimentation. So the idea is that we have the possibility and the ability to experiment on top of individual devices in an open approach. The second component refers to the service ability, to the ability to experiment in the service plane. So the idea that relying on the IoT devices deploy, the citizens, not just the companies, the research centers, etc., can design and assess new services relying on such technology. And last but not least, we have also provided the means for interacting the technology and the traditional services with other components like the social networks. So the idea of having semantic tools for identifying particular hot topics in different areas in the city also are managed by this third component. Here I present some of the examples in terms of the technology that has been deployed. We rely in all the facilities around the city, so the lamppost, the facades, the streets, but also we rely on the mobile devices, on public mobile devices, such the buses, but also the taxis, vehicles for parks, etc., etc. So this is the architecture that is being supported at time being in terms of infrastructures, cellular infrastructures, even not cellular infrastructures, or let's say more cluster-oriented infrastructures like the Sigfox one. And a nice example, I think that is better to present a picture, is how, let's say, the deployment looks like. So this is, for example, a noise sensor which is capturing real-time data for measuring how the noise is behaving in different points in the city. I will provide an example of how this initial experiment, the fact that we deploy around 64 low-cost sensors, later on became a key tool for making decisions at the city management level. Coming back to the presentation, these are also some of the examples in terms of additional services. So we have, besides having the typical and the traditional underground parking areas, we have, as you know, lots in the surface of in the streets. And one of the main problems is, as most of the cities experience, is that there is a lot of demand in particular areas during the day. So the traditional way in which that was managed is that the drivers were turning around an area trying to find the place. That was not possible. Finally, they ended by parking in the typical underground area. So 3-4 years ago, we started to deploy wireless sensors in the streets. We started with a bunch of around 400 sensors. And now the whole system is managed in an automatic way. So the idea is that even the responsibles for managing the system, they have acquired new skills. So before having such approach, they were using a paperwork approach. Now they use ICT techniques, ICT tools for creating the statistics, for designing the new needs in the future according to the present demands in different areas of the city. We also cope with the integration of new wireless sensor technology with the legacy one. So in the city, we had the traditional magnetic loops. So those traditional magnetic loops were providing the intensity in different areas in the streets, and we complemented such information with sensors at the entrance of the city, and that allowed to create a predictive model of how the traffic would behave in time frames of about 5 minutes in different areas of the city, alerting to the drivers on which areas or which directions should select in a prioritized way. I want to insist that this is behaving in a predictive way, not in a proactive way, not in a reactive way. This is important. So the environmental monitoring, as I mentioned before, so we deploy sensors for monitoring different air quality parameters. But the fact that we could not just rely on fixed sensors due to a trade-off between the extension of the city and the budget, we complemented such information with mobile sensors. And this is the reason for having this basis with, let's say, sensing capabilities for measuring traffic in different areas of the city. So this is the real-time map, for example, measuring, let's say, which is the status in terms of NO2, ozone, etc., conditions in different areas of the city, complementing the ones which gathering such information downtown with a fixed approach. So noise is an important issue, and 3-4 years ago, 3 years ago, once we deployed those sensors, we deployed just based on our, let's say, experience. So in the sense that, okay, that would be an additional parameter to be monitored. But what happens later on is that European regulation made compulsory to deploy or to create the noise maps in cities above 100,000 inhabitants. So what we did is to reuse those sensors for creating in real time the corresponding noise maps. And an important aspect is that those sensors are low cost. Low cost in that case means 1, 2, 3 euros. And the main issue is that those sensors are not compliant with what is called Class A sensors, high accuracy, etc., etc. So what we do is we integrate the values that we are gathering from those high-cost sensors with those deployed all around the city. The problem is that creating a noise map with Class A sensors is not really feasible. we are discussing costs about more than 10,000 euros per sensor. This is not realistic. And the noise map that is created based on these few sensors is not a map, which reflects the real behavior of the city. So here you can see this is how we are building in real time the map, interpolating the values that we are gathering, creating a grid or a mesh of sensors in the city, and this is the evolution of the sensing component during, let's say, around 1 hour, compressed here in less than 2 minutes. So the different noise sources that allows to create the map in different areas of the city. So an additional important aspect is the participatory sensing. So 3 years ago, we started with the participatory sensing approach, involving the citizens in the sensing, in sensing the city. So now we have a population of more than 10,000 inhabitants contributing in a proactive way to the sensing, but also to reporting events in the city. So the incentivization approach that we follow was the following. So we were interested in having sensing measurements from the citizens, but we needed to incentivize them. So what we did is we developed an application which is called the Pulse of the City, the Pace of the City. So this application allows to the citizens to report events happening in the city, traffic jams, accidents, waste management problems, etc., etc. And the only requirement that we impose to them, always in a voluntary way, is, okay, so we will really be glad if you share your data from your smartphone. And this is the way how we are gathering data from the smartphones in an based on an incentivization approach. So the idea is that we are coming, as you can realize, to this concept of an IoTized, what I call IoTized city, in which we have services, we have an experimental component, we have the citizens, and we need to manage such ecosystem. So the idea is that from around 2012, we make a decision, and that was an important decision because 3 years ago, fiber was near a no, I would say. And from the very beginning, we supported the idea of migrating, not migrating, but integrating the whole platform with the fiber platform or the fiber concept. So the instantiation of such a fiber concept is represented in this picture. So the idea is that we have all the vertical services running on top of the fiber platform. We rely in particular on one of the key concepts in fiber, which is the context broker, which provides contextual information, events happening in real time, plus the historical data relying on a Hadoop file framework, which is called Cosmos. Besides supporting in a concurrent way the services supported in the city, the experimentation, we also support the fact that experimenters, external experimenters, might have the interest to work on top of such infrastructure. And this is I would say, the slide which reflects how we have converged all these different ideas in one platform, which in parallel guarantees the interoperability. So based on such platform, we are supporting different experiments, not any kind of experiments, but several kind of experiments, and these are some of the nice experiments that have been proposed either in European projects, either by the citizens. This is one which detects the presence of an ambulance. So we have placed sensors with high computational capability in concrete areas, for example, near to the hospitals. And once we detect that an ambulance is approaching, we actuate on top of the lights, giving the priority to the ambulance. But a citizen proposed to use such sensors for detecting the graffiti guys, because you know that the graffiti guys, before they're starting to paint a graffiti, they shake the bottle, and then this is the typical noise. So the idea of triggering an alert for having the guy running out from the area. Another interesting experiment, not experiment, this is an European project. So we reuse the infrastructure, embedding sensors which allow to measure the electromagnetic field coming from the base station. So the idea is that we are measuring in real time the magnetic field, the electrical field coming from different base stations based on a dosimeter that has been deployed in those areas. So this is important because it allows to balance the traffic in different cells, to characterize how the electromagnetic field is impacted in the citizen, etc., etc. This is one of the first, I would say, extensive pilots measuring EMF at the European level. Just for ending, we are in the process of building new cities. Based on the experience that we got in the last year, so we believe that cities in the future will be autonomic. So the same concept of autonomic that we use in the networks, in the communication networks, we can apply to the cities. But for that, we need to have a holistic view of what is happening around the city. And one of the key enablers, at time being, that we are identifying is this concept very well known of semantic interoperability. We believe that based on the creation of this knowledge in the city will really operate not just in an autonomic way, but also in a predictive way, which is the final aim of the managers of the city. And this is one of the first steps in such semantic interoperability, not because it's one of the first projects, this is far from being one of the first projects, but it's one of the projects that tries, besides having the citizens involved in the creation of knowledge, in having new skills, also in promoting this semantic interoperability between cities aiming at having this predictive approach. So with that, I conclude the talk, and thanks for listening. Thank you very much.